Good day. So we are in our second to the last chapter for VEM007. I decided to have this chapter divided into 3 parts because this is quite long. And we will start with gestation. Gestation is actually the technical or medical term for pregnancy. So starting from now on, instead of saying pregnancy, you say gestation. So I'm sorry if there's a background noise of cats meowing because the cats are inside because of the weather. So when you say gestation, this is a period of pregnancy which usually starts upon the fertilization of the egg by the sperm and ends with parturition or giving birth. Parturition, on the other hand, is the process of birth, and it usually starts with the softening and initial dilatation of the cervix, along with the start of the uterine contractions, and ends when the fetus and its associated placental membranes are being expelled. Do you remember when we were talking about artificial insemination? I said the cervix will only be open twice. It can only be open when the female is about to give birth, and it can only be open when it's in estrus. And of course, lactation is the process of producing milk, which is a phenomenon you mostly observe in mammals. Although in birds, they also produce milk in certain parts of their anatomy. So a quick review or a quick overview, since supposedly you have embryology in the old curriculum, you had embryology before, but since this subject is preempting embryology, this is just an overview. So cleavage is a process of cell division without growth. Morula, a term for an 8-cell or 16-cell stage embryo. Placentation is the process of implantation and the formation of the placenta. And the blastocyst is a transitory stage that prepares the embryo for formation of the germ layers. So the germ layers are divided into ectoderm, mesoderm, and endoderm. The ectoderm, it will give rise to the central nervous system, which includes the brain and the spinal cord, while the sense organs like your eyes, ears, nose, skin, and tongue actually came from the ectoderm. The mammary glands, sweat glands, hair, hooves, and nails are also from the ectoderm of origin. Mesoderm, this is the middle. Ectoderm meaning the outer germ layer. By the way, mesoderm is the middle germ layer. So the mesoderm will give rise to the circulatory system, which includes the heart and the blood vessels, the skeletal system, which are the bones, your muscles, the reproductive system for both male and female, the kidneys, and the urinary ducts, like the ureter and the urethra. Endoderm is the innermost layer. It has the digestive system, which includes the liver and the pancreas, the respiratory system, thyroid gland, and most other glands. If the glands are located, let's say, near the brain, like the hypothalamus and the pituitary glands, they are usually of ectoderm or ectodermal in origin. So since this is pregnancy, of course, progesterone is the dominant hormone. We've discussed this in the previous topic. So this hormone is the dominant one in maintaining pregnancy, particularly during the earlier stages. High concentrations of progesterone will decrease the tone of myometrium and inhibit uterine contractions, as from Bearden and Fouquet. It is also downregulates the receptor sites for estradiol and oxytocin in the myometrium. Oxytocin is another hormone, which we will be discussing a little bit later. High progesterone will stop the cyclic estrus by preventing the cyclic release of gonadotropids, as you have seen in the previous chapter. And of course, it's released by the corpus luteum, particularly in the earlier stages, and the placenta, especially in the latter stages of gestation. Remember the prostaglandin that I have discussed in the previous video? Prostaglandin is an abortifacient. Why? Because it lyses the corpus luteum. So it has a luteolytic property, meaning it removes the corpus luteum. However, it can be countered by another prostaglandin, which is prostaglandin E2, which is an anti-luteolytic one. Relaxin. This is a polypeptide produced by the corpus luteum, as in the sows and cows, and the placenta, as in mares. The primary function of the relaxin, it softens connective tissue, which permits the uterine muscle to stretch to accommodate the growing fetus. It also allows the pelvic canal to expand, especially during late gestation. That's the reason why, as the fetus develops and grows bigger in size, the abdomen and even the hip bones will expand to accommodate the growing fetus. Methods in pregnancy detection, we have the ultrasound, endocrine detection, and of course, rectal palpation. So for ultrasound, you can have the Doppler, this one, ultrasound. This one does not detect actual fetus. However, it detects fetal heartbeat. You can adjust this one. So you put this in an area which is, as much as possible, you have to shave the area. And this is the probe, by the way. So the probe, you put it on the desired area, put some gel. It hastens the sound, and it will pick up the sound of the heartbeat of the fetus. Doc, how are we going to know if it's the heartbeat of the fetus that's being picked up? First and foremost, heartbeat of fetuses are usually higher than the normal range. For example, in dogs, because we used to have this with dogs. So for dogs, if it can pick up 180 to 220 beats per minute, because this is the monitor, this is where you can see the actual heartbeat that is being picked up by here. So that means it's picking up the heartbeat of that fetus. So that means it is pregnant. You can push, I think the volume is somewhere here. You can even listen to the heartbeat of the fetus. We also have this one. This is a B mode ultrasound. So on the notes that I provided in your module and in your SAS, you have there the difference between the A mode, B mode, and C mode. And I believe there's also a D mode, but I did not include that on the notes. So this is primarily used in our farm animals. This is handheld. This is quite portable. It might look portable, but this is quite expensive. Actually, the most expensive part of the ultrasound rather is this transducer. This is the one. And make sure you have a gel with you because it hastens the imaging. So you put this on the belly of abdomen of the animal, this one, and then put some gel, and then it will give you the image of the fetus. This is quite handheld, so it is widely used in farm vets, especially when they visit one farm to another. This is quite portable, but then again, size can be deceiving, and it's quite expensive. Now, this is an ultrasound of a bitch named Lucy. This is quite a long time ago. This is around 2013 when she got pregnant. So this is how the image would look like. I'm showing you an actual photo of a patient of mine. And I'm sorry if, although this is mostly livestock, but since my specialization is small animals, so I'm showing you some cases that we have. So this is an ultrasound of Lucy. God bless her soul. She's already dead. This was around 7 years ago. Yeah, 2013. So she was around 1 month pregnant, around 30 plus days pregnant, or 5 weeks most likely pregnant by this time. And the vet, I actually had her referred to the vet hospital because they have complete stuff over there. So I have to. So this is what you call the fetal ball. So this is actually, the fetal ball is actually the placenta. So each puppy is being encased into the placenta. And inside here, this one here, this is a puppy. So that means this is a positive pregnancy. You might be asking, Doc, what if the owners would like to ask if the animal, how many animals, particularly for litter-bearing animals, can the ultrasound count how many puppies, let's say puppies for dogs? Unfortunately, you cannot count. It's more on confirmation that they are indeed pregnant. Highly trained vets who are into imaging can also detect some abnormalities, but hopefully one of you will become an ultrasound, an imaging veterinarian, because in human med, among physicians, they also have experts on that, on reading ultrasounds and reading radiographs or x-rays. So you can, the best, if you really want to know how many puppies are there, you should have the bitch x-rayed. But the best time to have her x-rayed is around 2 weeks before she gives birth. Because by that time, the x-ray or the gamma rays from the x-ray is no longer harmful to a developing fetus. So, and make sure that you position the dog by its belly, flopping the belly. It's on its belly so that you can count exactly how many puppies are there. You might be wondering, why, Doc, why? Because sometimes when you do your ultrasound, the transducer, as I've mentioned, can pick up the image of another puppy in another horn. Let's say this puppy over here is on the right horn, but you can still see the puppy over here, which is actually on the left horn. So you can see this one, but not as visible. So I hope that answers your question. How about endocrine detection? So endocrine changes in the mare during pregnancy are particularly unusual when compared with other domestic species because of the development of the endometrial cups. So these cups produce the pregnant mare serum gonadotropin, or PMSG, which is now known as the equine chorionic gonadotropin. Quite a tongue twister. PMSG, or ECG, is first demonstrated in the blood of the mare around 38 to 42 days after ovulation. It will reach maximum levels at 60 to 65 days and will disappear by day 150 of gestation. This is quite tricky. So the record keeping from the farmer should be valuable. Endocrine detection is also being practiced in small animal. Just recently, newer technologies are available to us. So test kits are, a lot of our friends have already procured test kits for pregnancy detection. So if we have clients who are in a budget, that they cannot afford an ultrasound because it's quite expensive. It's around 850 pesos. They can want 850 to 1,000 depending on your location. So you can have the test kit, and it can actually detect RELAXIN. Yes. We also have progesterone tests, but it's usually in the preparation of pregnancy in animals. So just so you know, in case you really want to know. Of course, there's rectal palpation. This is the one that we usually do every Thursdays in our ruminant production laboratory. That's what's the reason that we don't take a bath every Thursdays, because it was around 7 to 10 in the morning. So we have to do rectal palpation during that time. And at around 11 to 12, that's our lecture. So cervix serves as guide for locating the structures as seen in the AI, rectovaginal approach. And the uterus, take note of the size, position in relation to the pelvis, and the thickness and tone of the uterine wall. So as the pregnancy or as the gestation progresses, it becomes thinner, and the dorsal bulge is detectable around 30 to 50 days in the uterine body. So uterine bulge is like, and we also have the chorionic membrane. So you might be wondering, what are placentomes? So I hope you did your review on the reproductive system, because included in the reproductive system is the placentation, hopefully. The type of placentation, especially for ruminants, since with rectal palpation, it's more applicable to ruminants, is what you call cotyledonary, wherein there are around 100 cotyledons located in the placenta, which is the fetal part, and 100 also these cotyledons are attached to the caruncles, which are located in the uterine lining of cows. So just so you know. You also have uterine contents. So this is the most positive diagnostic structures to be palpated through rectal palpation. Amnion is quite turgid and can usually be detected by palpating the uterine horns with the thumb and forefinger. It's actually just the thumb and forefinger by day 35 to 50 of gestation. So this is how we know how many days they are pregnant for cows. And the fetus is already palpable by day 60, except during day 170 to 230, wherein the fetus is too deep in the abdominal cavity. By the way, on the notes, I have there the gestation period of the different animals. So you know. Of course, the ovaries, they can be palpable. And then we also have the pulse of pregnancy, which is usually felt in the midline with the uterine artery. And this is by day 120, the midline artery will be enlarged enough to be useful as differential diagnosis in pregnancy. And the pulsion in the enlarged artery is much more forceful, indicating a great volume of blood flowing into the uterus, because it will provide nutrients to the growing fetus. Twinning. So this is a condition wherein a monotocous animal, when you say monotocous, an animal that can only bear one animal per pregnancy or per gestation. So they can conceive two fetuses. And there are two types, monozygous and dizygous. When you say monozygous twinning, this is called the identical twinning, wherein two fetuses that result from the fertilization of a single ovum. They always share the same sex and are genotypically and phenotypically identical. However, one can be larger than the other, as seen in human twins. Dizygous twinning is called are also known as fraternal twins. They may be of the same or opposite sex, but they do not share genotype and phenotype because dizygous twinning is the fertilization of two very different oocyte or ovum. So you might be wondering, oh, but did we also have Frey-Martinism? Mostly considered a problem in cattle, so the female twin is usually sterile, cannot give birth. So you might be wondering, Doc, is there a case of a dog who gave birth to twins? Yes, there was. I don't know when exactly, around 2017, but it was reported in New Zealand. A bitch gave birth to twins because they share the same placenta, and they're named Connor and Remus. Supposedly they should be naming them Romulus and Remus after Rome, right? Because Rome was founded by twins that were raised by wolves, but they named the other twin Connor. This was in New Zealand, so if you are interested, you can Google it if you want to. It was the first reported twinning in dogs because they share the same placenta. By the way, dizygous twins don't share the same placenta. They have separate placenta, while monozygous twins, they share the same placenta. Pseudopregnancy or pseudoparesis or pseudocyesis. This is usually manifested by bitches, to a lesser extent in queens. When you say queens, female cats. It was previously believed that the pseudopregnancy is due to an intensification and prolongation of metaestrus. I'm sorry about that. So sorry for the Doris Begonia moment in cats. However, researchers were able to demonstrate that there was no difference in the blood concentration of progesterone in bitches with or without pseudoparesis. It is likely that the hormone prolactin may be responsible for initiating the changes. This is usually seen during metaestrus, and there are two types of this, overt and covert. When you say covert pseudopregnancy, the bitch will be in metaestrus but will show little or no signs. And usually the signs observed are mammary development and lactogenesis. When you say lactogenesis, lacto means milk, genesis production. So it literally means milk production. This is for covert. While overt show the pregnancy, signs of this will include abdomen, enlargement of the abdomen, mock parturition with resting, like they even think they're actually pregnant, loss of appetite, straining, emotional attachment to inanimate objects, and heavy lactation. So we're done for this topic. So if you do have any questions, please do ask up. I really appreciate people who really ask. Until then, I'll see you later.